In this example, we're going to solve this linear system using substitution. So remember, the first step of substitution is to go ahead and choose one of these equations and then solve that equation for one of its variables. So essentially isolate one of the variables. So typically we're going to look for a variable whose coefficient is either 1 or -1, and that'll make it easy to isolate. So this x right here is a -1x, and the rest of them are 7, 3, and -8. So the 7, the 3, and the -8 are not good candidates. So I'm going to solve for x in this first equation. So what that's going to look like is, I know that this x is negative, so I need him to be positive. If I was to add x to both sides, he would be positive over here. And then it's just a matter of adding 9 to both sides to get rid of that constant. So I know 7y plus 9 equals x. So whenever I see the variable x, I can kind of associate the expression 7y plus 9 with it. So what's going to happen, I'm going to take this 7y plus 9, and I'm going to substitute it in for x, but in the other equation. And in that manner, we can combine these two equations together. So I have 3x minus 8y equals 1. So my value for x, we said, is this expression, 7y plus 9. So negative 8y equals 1. So I have this equation. Basically, I just need to start by doing the distributive property and then go ahead and solve for y. So 21y plus 27 minus 8y equals 1. So my 21y and my negative 8y will be 13y. And then if I subtract 27 from both sides, I'll get negative 26 over there. So my value for y looks like it's going to be negative 2. So now that I know the value for y, I need to plug it back in to solve for x. So if I were to plug it back into one of these original equations, I could plug it in here or here, but then I would have to go to the trouble of solving for x. But remember, didn't we do that already at the beginning of the problem? Here we already solved for x. X equals 7y plus 9. So since x equals 7y plus 9, I'm going to put this negative 2 in for this y. So 7 times negative 2 is negative 14 plus 9, and that equals x. So negative 5 equals x. So now that I have both values for my variables, I can write the solution as an ordered pair. My x is negative 5, my y is negative 2. So here's the solution, this ordered pair, and it's going to be the solution for this linear system. And what that means is that if I was to graph these two lines, I would notice that their single point of intersection is this ordered pair, negative 5, negative 2.